This is Leetcode problem number 189, and it says rotate away. So given an array, rotate the array to the right by k steps where k is non-negative. So basically there's an array given. Suppose this one. It has 5 elements, and suppose k is equal to 2. That means I need to rotate the array by 2 elements to the right. So here 4 and 5 are the last 2 elements at the right. These 2 elements are going to be placed at the start of the array, so 4 and 5, and the rest of the elements are going to be placed after those 2 elements, 1, 2, 3. So as you can see here, that apart from the last 2 elements, all the other elements have moved 2 places to the right, as you can see. And basically we can consider this as 2 blocks, right? This is 1 block, 4 and 5, and 1, 2, 3, this is 1 block. And the relative positioning among the elements in each block remains the same. As you can see, in the original array, the second block was 4, 5, and here it's 4, 5, and this block here is 1, 2, 3, and after changing, this block remains the same, 1, 2, 3. So basically what we can do here is traverse through the entire array starting from the right. Okay, we'll start from the right, and since we need to bring the last k elements to the front, we're going to keep on pushing elements into a stack or a queue, and until the stack or the queue has k elements. But I would prefer using a stack here because, see, from right to left I'm taking 5 and then 4, so the sequence is reversed, right? But I need to, maintain the original sequence, and the original sequence, the only way I can get back the original sequence is if I keep these elements inside a stack. So I push in 5, then I push in 4, and because the stack is last in first out, so I'm going to be able to get the original sequence back. So once I get k elements inside the stack, the next elements, all of them, are going to go 2 places to the right. So 3 was at index 2, is going to move to index 4. 2 was at index 1, it's going to move to 1 plus 2, that's index 3. Similarly, 1, it was at index 0 at the original array, it's going to move to 0 plus 2, that is index of 2. And after that, once traversal is finished, I just need to pop out the elements from the stack into the array, and I'm going to start from the very start of the array. So 4, and then 5, right? Here, 4 and 5. So that is basically the way we can solve this. So we need a stack to keep k elements, which are placed at the end. We're going to use a variable that is count, that will keep track of how many elements I have so far kept in the stack. And I'm going to be traversing from right to left. So nums.size -1 is the initial value till 0, of course. Of course, we are decrementing the value of I. So if my stack dot size is less than k, I'm going to push the current element inside the stack. Else, as I said, I'm going to move the first three elements to k positions at the right side. Else nums I plus k equal nums of I. And now we have the k elements inside the stack, the last k elements, and we will just pop them out. So we're going to put them in the start of the array. So nums of I will equal my stack dot top, and I'm going to pop it. So that is pretty much the solution. Yep. Okay, is there something missing? One-time error, reference binding. Greater than my stack dot push. We don't need to return anything, so the error is reference binding, which is my stack into 0 count. Size, is it length? No, it is size, I think. Four byte alignment, misaligned address binding. Dot top. Nums of I plus k equal nums of I. So if it's -1, 2, okay, so if okay, so what we need to do here is k equals k modulus nums by size. This should work. Yeah, it does work. And that is because, suppose I have 5 elements, and there might be that k is equal to 6, but I have few lesser elements, and so if I make 6 rotations, that means I'm actually doing 1 rotation, right? Because rotating it 5 times would give you the same array, basically. So that's what I did. I divided k by nums.size, and whatever the remainder is, that is the number of times I need to actually rotate the array. So that's it. Hope you guys enjoyed it. I'll see you again soon.